Hello, welcome to section 5.5 on indefinite integrals with the substitution method. And to kick off, first we need to recall what this is, an indefinite integral. That refers to the general antiderivative of a function, or the set of all antiderivatives. So we actually saw this back in section 4.7 at the end of last chapter when we first started looking at antiderivatives. We got this idea of an indefinite integral. So the integral of f of x dx, that just referred to the general antiderivative. So if big F of x is the antiderivative, we would have capital F of x plus c. And that plus c was very important there because that makes it the general antiderivative since that constant could be anything. But the overall idea here, notice that our result that we're getting from these is a function. Okay, so it would still have perhaps the variable x in there. We would still be able to plug things into it. We're getting a function out of this. Now, we want to contrast this with definite integrals. Those are the ones that have limits of integration. So when you see something like the integral from a to b of f of x dx, the result here is not a function anymore. It's just some value. Okay. So yeah, the result here is not a function. It's a number or value. Okay. Now, on rare occasions, we might put some perhaps other variable in one of the limits. Those are special cases here. Definite integrals, we have a lower limit of integration, upper limit of integration, and we'd end up plugging in those values. Okay, so function versus value. All right, now we want to look at this idea of an indefinite integral here. We're going to save definite integrals until the next section. But for indefinite integrals, we need to do a little bit of navigation here. All right, so we are going to make a little map, kind of like Google Maps or something. And we're going to start by being given an integral problem, the indefinite integral of f of x dx. Okay, so starting location. And, you know, if everything is set up nicely, if all is well, you might be able to find the antiderivative of this right off the bat. Maybe it would take a little bit of thinking, but you could do it, no stress. And you would come up with that general antiderivative, capital F of x, plus c to keep it general. Okay, and that is our ending point. We want to arrive at the general antiderivative answer for this indefinite integral. So yeah, again, this is like the ideal path, but sometimes it's not that easy. Sometimes we need to take a slightly longer route here. There are going to be some indefinite integrals that you're given where you can't just come up with the general antiderivative off the top of your head. You're not going to be able to take that ideal route. And so we need to go the longer way. Okay, so what we're going to do here, our alternative route, is to use a substitution. And we're going to let the variable u represents some portion of this indefinite integral. We're going to call it g of x, just so that, you know, it doesn't have to be like the entire integrand there, and really it's not going to be if we're using this method. So you're going to make this little substitution, stop off there. Okay. And when you do that, you're going to be able to transform your original problem. Instead of being the indefinite integral of f of x dx, now you're going to have an indefinite integral in terms of this new variable u. Okay, so it's going to be the indefinite integral of f of u du. Okay, so that's our next stop. And the plan here is that the substitution we make, u equals g of x, we want that to simplify the integral enough that we can actually find the antiderivative of this guy right here. Find that general antiderivative of little f of u du. Okay. And so we would take an antiderivative and get capital F of u plus c. But as you can see, we are not at our final destination yet. We need to pass back through this substitution. We need to put back in whatever we had let u equal. Okay, so you put back in that g of x expression. That'll put your answer back in terms of x, and that'll take you to the ending point, the antiderivative or indefinite integral of big F of x plus c there.